Day 766 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2161, partition array according to given pivot. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero-index integer array nums and an integer pivot. Rearrange nums such that the following conditions are satisfied. Every element less than pivot appears before every element greater than pivot. Every element equal to pivot appears in between the elements less than or greater than pivot. The relative order of the elements less than pivot and elements greater than pivot is maintained. More formally, consider every pi, pj, where pi is the new position of the ith element and pj is the new position of the jth element. If I is less than j and both elements are smaller or larger than pivot, then pi is less than pj. Return nums after the rearrangement. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input nums equals an array of integers 9, 12, 5, 10, 14, 3, 10, pivot equals 10. So that means, since pivot equals 10, that means every element less than pivot is going to appear before pivot, and every element after or greater than pivot is going to come after pivot. Hold on. Right here, yeah, every element less than pivot appears before every element greater than pivot. Boom. So let's go through the this output, right? We have 9, 5, 3, 10, 10, 12, 14. So as you can see, pivot is 10. We took all the numbers less than 10, put them on this side. We put all the numbers greater than 10, we put them on this side. We put the two 10s that are equal to each other in the middle, right? So that's what this is saying right here. Every element to pivot appears in between the elements less than and greater than pivot. Boom. Sorry. So that's how that works. You see we have a 9, which is less than pivot. We have a 5, which is less than pivot, and we have a 3 that is less than pivot. It says right here, the relative order of the elements less than pivot and the elements greater than pivot is maintained. So we're going to maintain this order, 9, 5, and 3, right? That's why we have this 9, 5, 3 before the 10, even though that it's not in sorted order. It's not supposed to be in order. It's supposed to maintain the same order that it was in the input array, right? So it goes 9, 5, 3. That's less than 10. Then we have a 10 right here, and we have a 10 right here. So we'll put them right here in the middle of the elements that are less than and greater than pivot. So as you can see, we have 12 and 14, both are greater than pivot, so we put those right here in our output after pivot, and in the end, this is what we're left with, y'all. So once again, it's the explanation says the elements 9, 5, and 3 are less than the pivot, so they are on the left side of the array. The elements 12 and 14 are greater than pivot, so they are on the right side of the array. The relative order of the elements less than and greater than pivot is also maintained. 9, 5, and 3, 12, and 14 are respective orderings. All right, y'all, so just in case that didn't make sense, let's take a look at example 2. So in example 2, we have an array of integers -3, 4, 3, 2, pivot equals 2. So once again, we have our output, an array of integers -3, 2, 4, 3. So once again, all the elements less than 2 or less than pivot go on the left. All the elements greater than pivot go on the right. Pivot goes in between or in the middle of those. So once again, we have a -3, that's less than 2, so we put that right here. Boom. That's the only element less than 2, so the next element will go 2. Boom. Now 4 and 3 are both greater than 2, and in the same order it goes 4 and 3. Remember, we have to keep the order, so we put this 4 and 3 after the 2. And that's how we got this output. Explanation says the element -3 is less than the pivot, so it is on the left side of the array. The element 4 and 3 are greater than the pivot, so they are on the right side of the array. The relative ordering of the elements less than and greater than pivot is also maintained. -3 and 4 and 3 are respective orderings, y'all. So boom, I hope that makes sense. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, the first thing we want to do is we want to create a result array with the same size of nums, and it is initially filled with zeros, which just for the default value. So we are going to come right here. We're going to declare a variable called result. We're going to set that equal to an array. Open up the parentheses. It's going to be repeating colon 0. 0 for the default value, and it'll be count colon nums dot count. Boom. Now we're going to create 2 pointers. The left is going to track with the next available position for values less than pivot, and the right is going to track the next available position for values greater than pivot. So we'll come underneath this. We'll declare a variable called left, set that equal to 0. Declare another variable called right, set that equal to nums.count minus 1. Boom. Now we're going to traverse the array from both directions at the same time. So we'll come underneath this. We'll say for I and 0 dot dot less than nums. We'll open up, nums dot count, not nums. Boom, put nums dot count. We'll come right here, and if the current value from the left side is less than the pivot, place it at the next available position on the left side of the result array. So we're going to say if nums square bracket I is less than pivot, we'll open up the brackets and we'll say result square bracket left. Come outside of that equals nums square bracket I. Come underneath that, we'll say left plus equals 1. Boom. Now we're going to check the corresponding value from the right side. If it is greater than the pivot, place it at the next available position on the right side of the resulting array. So we come underneath this if, and we say if nums square bracket nums dot count minus 1 minus I is greater than pivot, then we'll open up the brackets and we're going to say result square bracket right equals nums dot count minus 1 minus I. Come underneath that and we're going to say right minus equals 1. Boom. Now after placing all values less than and greater than the pivot, the remaining positions between left and right must contain values equal to the pivot. So we come underneath this, we'll say while left is less than or equal to right. We're going to open up the brackets and we'll say result square bracket left. Come outside of that equals pivot. Come underneath that, we'll say left plus equals 1. Boom. Then we need to return the rearranged array by coming underneath this, where all values less than pivot are on the left and all values to the right of pivot are on the right. All values greater than pivot are on the right. And pivot is in the middle by saying return result, y'all. Boom, that's all we had to say. So let's go ahead and run this, make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.